Is about transformations of exponential and log functions. So on page 169 of your student journal, the first thing I want you to do is just go ahead and match each function with its appropriate graph. Okay? The goal is to see how you can transform graphs of exponential and log functions here. You work together?
When does this equal?
All right, ladies and gentlemen, can I have your attention, please? Not always. It's always blinking. Okay. So let's see what we've got here. Graph. Or excuse me. Let's look at it based upon graphs. So graph A. What function goes with graph A? Function C. I'm going to use a pencil here just to make sure, just in case we make mistakes. Okay. So function C, so we'll write g of x is equal to e to the x minus 2, all minus 1. Okay, so we say it's function C. All right, what one goes with B? Everyone agree F? Okay, g of x is equal to 2 plus natural log of the opposite of x. Okay, how about C? B, okay, let's see, g of x is equal to the opposite of e to the x plus 2 power, all plus 1. Let's do that. D, okay, so we hear a bunch of e's now. Okay, we'll say g of x is equal to 2 plus the natural log of x. All right, how about E? D? Okay. Hey, we're not saying they're necessarily right. I'm just going for the majority right now. We'll check. Natural log of x plus 2. Okay, and how about F? A. So we get, it's the last one there. G of x is equal to e to the x plus 2. Not a very good looking x there. All minus 3. Okay. What process did you use to match them up? Aaron? Okay, without using the calculator, what process did we use? Yeah. On A? Okay, so can you describe that again there?
Well, for the function, it has the -1 here, or -1.
Okay.
So and then on the graph it has down 1. So
okay, so you're just like, well, it looks like it shifted down 1 because of that -1.
Yeah.
And there's no other -1, so anyone use that process? Okay? All right. Good. So that's like a K-shift. Any others? Matt?
We were looking for the points. So on a regular exponential graph, it's 0, 1. So we were looking for that point on all these graphs.
Okay, so if we had y equals e to the power of x, you're saying that first we need to know that that's growth, and when you plug in 0 for x, you get 1 for y. Okay? And so how did you use that? So like for this one, it's normally 0, 1. So we are usually right here.
But then you have the 2 and the -1, so you shift over to the right 2, and then down.
Okay, so similar. Still using shifts there. Anyone else do that? So go over 2 and down 1. You did that? Okay. Does that work on all those? Maybe if I go here. What's this mean? Natural log of negative x. What's that negative do? Flips it which way? Okay, here, you guys, I'm going to rewrite this one in here. I really am. I'm trying to ask a bunch of guiding questions right now. That's like educationese for me trying to teach you, okay? But you actually stating the answers and kind of going through the learning process here. But if I rewrite that like that, what is that to? In terms of what we studied this year. Okay, let's go back. We have studied these different things. A, B, H, K. We've also studied a C in there, but which one is that? That is our K value. It is a horizontal, or excuse me, a vertical shift. What is this negative in here? Okay, so we'll go back to, is it with X or not with X? It's with X. When it's with X, what is it? It is horizontal. So this means I am flipping it. It means it's a reflection, but which way is it reflecting? Over the y-axis. So first you have to know that a natural log, or a log graph, which this is, a natural log, that does this. Versus a growth graph, which does something like that. So we've got to think, okay, this graph started something like that. Okay, here's the y-axis. Okay, I know it's not an amazing y-axis. Okay, and then we flip it. It's now over here. Right? Not an amazing reflection, but that's supposed to be, okay? So it does that. That's what happened there. Then what happens? Up. It goes up too. So thinking to what Matt said a minute ago there, we're talking about this graph, e to the x, it crossed y at 0. Right? What's the natural log cross at? It crosses at 1, 0. And so if I reflect it, and then I add 2 to it, that 1, 0, this really is not an amazing picture of it. Okay? That 1, 0 is going to then move up. So what was 1, 0 right here got reflected and became there, and then it moved up 2. It's now right there. Okay, it's important that we learn the shifts, right? Okay, I know that I've tried to, we've used the calculator a lot this year at different times, but we really do need to be able to look at those shifts and go back to our parent function, which is what this is, and kind of what that is. It's not an amazing picture of it, but we'll do some more graphing of parent later. Okay, so here, the parent function is e to the power of x, means it starts here. Okay, what do we do to it? Okay, we go to the left 2. We're now there, and then what? That's that. We've got to do something else before we add 1. We reflect it, so kind of work your way inside out, reflect it over the x-axis, so now it's down here, and now what? Go up 1. Hey, we're there. All right, so the x and y intercepts are the key pieces that we're keying in on here. So here, so again, it's probably best to write it in this format. Okay, we start here. What do we do to it? Just go up 2, based on that. Okay, describe your neighbor the shifts on letter E and letter F graph based upon those functions.
Yeah, left 2, and then F is... No, down...
F is... Oh, wait, X.
Down.
Oh, down 3.
Yeah, and then...
Left 2.
Yeah. Is that right?
Oh, I cut it this morning. That's what I do. Not on a pencil sharpener. No. Yes. Thank you for making sure. Okay, let's wrap it up here. We usually start at that point. From here we are going which way? Left 2. Hey, brings us there. This one starts here, and we are going
Left 2.
Left 2, and
Down 3.
there we go. All right. Hey, I'm not going to write down the shifts, which it actually tells you to do, or the transformations. I will put up a sheet here in a minute to list those that we just talked about. But I want you to go through, on the next page, Exploration 2 actually says find the domain and range and asymptotes of each graph. I want you to list the domain, the range, and the asymptotes of each graph. Okay? There you go. Domain, range, and asymptotes of each graph. Okay, here we go. Only done 2 of them. Okay, what's the domain here? What's the domain on all of these?
That's not how it works.
All real numbers?
Wait, that's not. Wait. It's all real numbers for A. Yes, for A.
Nope, keep going.
A, F, C. A, F, and C.
A and
I'm saying it's just
A, F, and C. A, C, F.
A, C, and F.
okay,
That's what we just had.
ladies and gentlemen. Hey, let's focus back up here. First, if you're looking graphically, the domain is all real numbers for A, F, and C because it keeps extending forever on the horizontal. Now, the other thing to think about, A, F, and C all deal with these functions up here, right? These are all exponential, meaning you can put any value in for x and get an output value. That's what that means. When you say all real numbers, that means it doesn't matter what you put in for x, you will get an output. That is not true on these. You can't put in any value for x and get an output. Therefore, the domain changes when you're in a log. Okay? So on this one right here, letter B, if we're just looking at the picture, it looks like it goes on forever this way. However, it stops where? Yeah, using this as our number line, it stops at 0. So my domain is x is less than 0. Can it be equal to? No, because that's your asymptote. X equals 0 is the line it's approaching. Make sure you label it as x equals 0. You can't just say 0. You've got to give the equation of the line. Okay? What's the range on this one, though? All real numbers. It extends up and down forever. Whereas these graphs, exponential, do not extend up and down forever. They actually, this one goes to y is greater than -1, and my asymptote is at y equals -1. Okay? Guess I should have been on the screen there. But. This one, my range, y is less than 1. My asymptote, y equals 1. This one, my domain, x is greater than 0, and all real, x equals 0. Here, domain, Hey, any questions there? All right, so we've spent enough time just kind of matching things up. Let's try to do some graphing. Turn to page 173 of your student journal. By the way, on 171 and 172, there is a summary of all those transformations again. So, and some examples of them, if you want to reference back to those. But I would like you to look at page 173, and I want you to graph number 1 with your groupie there. And then describe the transformation of f to g. I'm going to go up by 6s. Or actually go up by 2s, I mean. Okay. When I'm graphing f, that's 6 to the power of x. What's my y-intercept? That's going to be my common thread here. So if I'm going y equals abx, a is my y-intercept. Why? Because when x is 0, what's b? 1. When I put 0 in here for x, I get 1 out. And that means a is my y-intercept. It's going to be 1 times a. Okay? Remember, your y-intercept is always when x is 0. Hey, you talking back there. Not good. So there are 3 of you just a minute ago. Be done. Pay attention. That way when you are trying to graph these later, you will know what to do. You can thank me later. Okay? Y-intercept is 1. It's not 6, it's 1. Okay? So we're right there. That means when x is 1, that's our b term. Right? So when x is 1, we put 1 in here, we get 6 out. When x is 2, what do we get out? Yeah, we get 36 out, right? Is that going to fit on this graph? No. But when x is -1, what do we get out? You get 1/6, which is way down here. So what ends up happening, right? Since we're not shifting, we know it's going to approach the x-axis. It's going to go through 1. It's going to hit 6. And then it's going to jet up really fast. That is f. And I'm going to label both legs there. Now, when I'm graphing this one, what am I doing to f? Good. If you can think, hey, I'm adding 6, that means you're just taking this point that you've already graphed and adding 6. You're taking this point you just graphed and added 6. You're taking this point we just graphed down here, and we're adding 6, which means right there. This whole graph is shifted up 6. And that means it starts jetting up really fast once again from there. I don't know if jetting up is a mathematical term. However, there we've got it. Okay, describing the translation. The translation, or the transformation, it's a translation up 6. Okay? Not too bad, right? Okay? Let's go on to number 2. They get progressively funner, or more funnest. What are you talking about? I don't know what you mean. Jacob, thank you. Super swell. All right. Okay, we're going to finish this page, and that'll take you like 2 minutes. All right, here we go. Y-intercept is?
1, 2, 1.
It It is 1. Once again, A is 1 there. Y-intercept is 1. I'm going up by 2, so I'm going to put it there. E to the x, what is E? 2.7. So whatever your base is what your first value for x is. So when we say 1, we put that in. We get 2.7 out, unless A is a number other than 1. I mean, then you've got to multiply by A. But in this case, we get 2.7 out. It's about right there-ish. Okay? And then we put 2 in. That'll actually work. If I go E squared, I get like 4 point something, yes? No. 6 point something, right?
7.39.
That's what I meant. 7 point something. Okay?
Like, go like 7.5.
Okay, and we cannot get 4 out, right? And get a value. We do the same thing about there. So we start cruising like this. It does not cross x equals 4, at least on our graph. There we've got it. There's the graph of f.
Is that 4 or 3?
What's that?
X is x equals 4 or x equals 3. Like, it doesn't cross. Okay.
It won't go past. I mean, it will eventually, but not on our graph.
Yeah, I know. But you're saying like it won't go past. It won't cross x equals 4.
X equals 4. Did I say 3?
Yeah.
I meant 4. Yeah, we can't. We'd have to calculate 4. It doesn't fit on there. Thank you. Okay, so this one, what are we doing with it?
You're shifting it.
Matt? 4 right. Okay. So we're going over 1, 2, 3, and 4. Here we're going over 4. Okay. Here we're going over 4. And then we're going over 4. Okay? And so we're not going up or down, so it's still getting infinitely close to the x-axis, but everything is shifted over 4. All right.
Next.
What do you guys think?
I think.
Okay, so
Number 3.
translation.
Right.
All right. Translation right 4. Okay, let's do some fun. Number 3.
Hey!
Woohoo! Score!
I'm happy about that.
I'm pumped too. All right, hey, let's graph the log one together. Because the other one, let's graph f together. G, we will also graph together, but it looks a little more fun. Okay? All right. So, now you'll notice I put it in the center on this one just because I know this one is shifting. Okay, and we have 1/2, and I'll be able to get it all in there. And even more importantly, I've graphed it at one point, so I know where it's going to be. Okay, so log base 5 of x. Let's think back once again in here. If I'm looking at this, and I put 0 in for x. What's my output? Okay, so let's go to this form. Y equals a log x. Okay, just the basic format. A log x. A is my when I put 0 in for x. Okay, here. Let's write that exponentially. Come on, what base is it? 10. So it's equals ax. Thank you. Okay. Okay. So let's put 0 here. What do we get? You get 1. When y is 0, x is
Off screen.
x is 1 times a, right? Or in this case, a is going to be 1. All right? This side will have to give you 1. Yes. Yeah. A is going to be your intercept. So based on what we have right now, so let's pretend we don't have the a for a minute. Okay? When y is 0, a is 1, or x is 1, yes? If we have an a, we'd have to multiply 1 by whatever. So in other words, our a value is our intercept. So if I'm looking at this, what is my a? 1. Therefore, my intercept is 1. Okay? Which intercept are we talking about? Well, we're talking about not a y-intercept anymore. We're talking about an x-intercept. Okay, so I'm going to make this a scale of 5 here. I'm going to make this one a scale of 10. Or excuse me, from negative 10 to 10 and 5 to negative 5. Okay? So my interval on the x is going to be 2. My interval on the y is going to be 1. Okay, so what I'm going to do is I am going to, on my log graph, rather than going with a y-intercept, I'm going with a x-intercept. So a key note there. Exponential graph, you're going to a y-intercept. Log graph, you're going to a x-intercept. So my x-intercept is at 1. So since I'm going up by 2's, it's right there. What's that? Yep, so 1 there. Oh, okay. Okay. And then from there, what's my base? Yeah. Question?
Could you move it over so we had 5 to the y and then equals x?
You could, but it's gonna be easier to use your shifts this way. So I'm gonna show you this method, and we're gonna use the shifts that way. If you want to do that, you can. Okay? So from here, my base is 5, so it works just like an exponent. Like when we did this one, our base was 6, so when x was 1, we went up 6. You guys with me on that?
Yes.
Okay? Here my base is 5, so it's backwards. All right? So rather than going over 1 and up 5, we go over 5 and up 1. So there's 2, 4, and 5, and up 1. And then we go, what's that? No, I'm going up by 2's on the x-axis, right? No, it's not from that point. No. It's the order pair. It's the order pair 5, 1. So if, like Emily asked just a minute ago, hey, she said, could we graph this, could we put it in exponential form? Think of this as y equals log 5 of x, and then rewrite it as 5 to the power of y equals x. You could do that, and then pick values for y, right? So when y is 0, x is 1, correct? When y is 1, x is 5. When y is 2, x is 25. Okay, let me finish this thought, Rory. When y is negative 1, what's x? 1/5. And so it's approaching the y-axis here. So if that's easier, and quite honestly, that's how I usually graph them, do that. But then when we talk about shifts of graphs, I want us to be able to look at log format and be able to say, okay, we just graphed this, but I want to shift it this much. I want you to be able to recognize how we shift that graph using that format, which we'll do here in a minute. So Rory, what's your question?
So that the one with, I guess, to the first power, do you move it 5 or do you go to 5?
You go to 5. Yes. It's an ordered pair. So this would be the ordered pair 5, 1. When y is 1. It's just backwards. It feels backwards and long because it's an inverse. Okay? All inverses are kind of goofy like that. Okay? So, if I'm doing this one, what's happening? What does the plus 7 do? It moves it to the left 7. Right? It's with x. It's moving it this way 7. Because it's an inverse. It's moving it that way 7. Okay? And the 1/2 does what? It's a vertical shrink, right? So everything's going to be, if it's a vertical shrink, everything's half the distance. Let's remind your neighbor real quick what vertical shrink does. Which axis is it pulling away from or pulling towards?
It's pulling the number towards it. No.
Okay, you're getting closer to which axis? To x. You're shrinking towards x. Okay? So, if I'm saying I'm moving my points over 7 and I am shrinking half the distance to x, okay? Well, this is on x. It's not going to shrink towards it anymore, right? So this one just goes over 7. It's right there. This one is half the distance from x. So right now it's how far away? 1. So it's going to go back 7 and shrink. Okay, it's going to go let's see, 1, 2, 3, 4, 5, 6, 7, and half the distance. Okay, and these are going to be such negligible points and distances on this graph that we're not going to be able to do anything with. We're not going to be able to see that difference. But we do know our asymptote now, which was at x equals 0, is now going to be at x equals. It also moves back 7, right? So it's got to be at x equals -7. Okay, so if we draw that in there, our line, our graph is going to approach that. And then it's going to be really, really skinny. Okay, and then my question is, at any point, can I find a value for x that's actually going to stay here? That we're going to be able to see out here on y. So let's say I put, 8 in for x. What's 8 plus 7? 15. Is that a power of 5? Is that like 5 to the first power, 5 to the second? Is that it? No. What could I put in to get a power of 5? 18, right? That would give me 25. So I'm not going to see it. It's going to probably do this stuff. It's not going to actually cross that 1. So we're going to have that like there. Okay? 18's not on our graph, so that's what we've got. Your assignment today is to finish those 3 graphs and to do the puzzle time that I'm about to give you.